So we're continuing on, sticking with exponentials and logarithms. Those are very important skills we've mentioned before. And what we want to focus on today are financial models. This may be some of the most practical material that you'll find in this course. Might be useful to you throughout your life. So you don't have to rely on the financial planners or what they tell you when you go into a mortgage office and that kind of a thing, or you're buying a car, that sort of thing. So what we want to do is work on this today, and what we can do is start out by looking at some numerical patterns and then sort of see how we can actually build an equation then that'll describe, say, an investment and how an investment might grow. So I think what would be useful is I actually was thinking about this last night and thought that what we might do is start with, let's say we're investing $1,000. And let's say we're going to give it a 6% annual rate of return. 6% annual percentage rate. And we typically just call that the APR. You can go into any bank or credit union and see a chart that'll tell you what the percentage rates are. They'll also tell you something what the effective yield is, the effective yield or the effective rate of return, and we'll talk about that in a few minutes. Okay? So let's say we invest $1,000, and then right now, when we first start the investment, we have $1,000. After 1 year, and we're only going to get the interest, the earnings, once a year. So we'll keep it real simple to begin with, and then we'll start looking at it if they give you some return every month maybe, or every day. Okay. So after 1 year, you're going to have $1,000 plus what? 6% of the 1,000. And remember, percent means per 100. So that is 6 hundredths. Those are equivalent. Those are equivalent statements. And that fraction even reduces to 3/50ths, but we usually don't write it that way. What we usually do is write it how? 0.06. Okay, so all three of those are identical. So we're going to add that interest rate, or interest percentage, times the amount that was there. Now, what happens at 2 years? So here we have a chunk of money. And what I'd like you to notice about this is that this is equal to $1,000, if we factor that out, times 1 plus, if you factor out the 1,000, we have 1 plus 0.06, and so we have 1.06 right there. 1.06. Is that right? Pretty comfortable? Feel good? Okay. Now, let's see what happens after 2 years. So that's how much money you've got. In other words, you can multiply that out, and you're going to end up with $1,060 after 1 year. Okay. After the next year, after 2 years of time passes, you're going to have that 1,060, but the way I want to write that is I want to write it as the 1,000 times the 1.06. Okay, that's how much you're starting with at the beginning of this second year. And then you're going to be adding to it the interest times that amount of money that was there at the beginning of the year, which again is this 1,000 times 1.06. Now, if you look at this pattern, we could factor out what's common. We could factor out this 1,000 times 1.06. We see it here, and we see it right there. So if we factor that out, we would observe that we have the 1,000 times 1.06 factored out in front, and then what's left once you factor that out is again a 1 here plus 0.06, another 1.06. So what we can see is that we clearly have a pattern going on here. we have, I'll write it over here on the right, 1,000 times this 1.06 raised to the 2 power. After that first year, we have 1,000 times the 1.06 to the 1 power. And initially, when we first started, we just had our $1,000, but we could put 1.06 raised to the 0 right there. So everybody see that we have an exponential model? We have the initial investment times 1 plus the percentage rate raised to the number of years that the investment's been made. That feel okay to people? It's very simple. Sure. Get out of the way. Okay, right, okay. There it is. So in general, let's say we went for t years. For t years, then our investment, and let me just check something in the text. Just to make sure I'm going to be using the same symbolism. In t years, then, we're going to end up with a certain amount, as a function of time in years, that is going to be equal to, it looks like, in this model, $1,000 invested times 1.06 raised to the t, that being the number of years. Very simple. This is actually almost a very early in algebra kind of pattern stuff. You've probably seen this multiple times before. We're going to make it a little more complicated in a couple minutes though. But now with your background with exponential functions, you can see clearly that this is an exponential function, where the y-intercept, if you wanted to generate a graph as a function of years, the amount that you've got as a function of time, the initial value at time 0 is $1,000 here, and there's your y-intercept. And this is growing at a multiple of 1.06. So after 1 year, you're going to be at 1,060. After 2 years, you're going to be whatever that calculated value would be. It's going to be something more than just another $60. So it's going to be a little steeper. And it's going to continue to grow with an upward curvature like that. It's an exponential model where the base is 1.06. Base is slightly bigger than 1. Should be very comfortable. The way you oftentimes write this model is A of t. This is called the, whoops, this thing is dangerous. A of t, this is called the future value. Is equal to the initial amount. This is the initial amount of the investment, oftentimes called the present value. The reason it's called present value is because oftentimes you're talking about things from now into the future. Times 1 plus the annual percentage rate raised to the t, where this is the APR, annual percentage rate, as a decimal, and this is the number of years that you have invested this. This is called simple interest. If you only get your return once a year, simple interest.
Isn't that P subscript 0 usually, or A subscript 0 usually for P?
Right here?
Yeah.
Yeah. And I was just keeping the symbolism the same. So it depends on what book you happen to pick up. But you'll see this oftentimes, and I could go ahead and change that. I think our book uses, anybody notice yet? I think it's P. Yeah, we always typically use P there, and I'll go ahead and do that as well, just so we're consistent. Okay. So that's an important model. Now that's very, very basic. Let's see what happens with an investment if you are given the interest return more frequently than just once a year. This is then called compounding. Okay. Later today.